Hey everyone, welcome to the Code Wizard. We are excited to share our latest tutorial on chemical equilibrium made easy with Python code. If you are new to our channel, make sure to hit the subscribe button and turn on notifications so you never miss a video. And if you are enjoying the content, don't forget to give us a thumbs up. Let's dive into today's topic and unlock the magic of programming together. Chemical equilibrium is a state in which the concentrations of the reactants and products in a reaction remain constant over time. In order to calculate chemical equilibrium using Python, we will first need to understand the basic principles of equilibrium and how to represent it mathematically. The equilibrium constant Kc for a reaction can be calculated using the equation Kc equals products, reactants, where products and reactants are the concentrations of the products and reactants at equilibrium. To calculate the equilibrium constant, we need to know the initial concentrations of the reactants and products and the equilibrium concentrations of the reactants and products. In order to calculate the equilibrium constant using Python, we can use the Scipy library's quotient function to solve the differential equations that describe the reaction. The quotient function takes as input the initial concentrations of the reactants and products, the rate constants for the reaction, and the time at which we want to calculate the equilibrium concentrations. To illustrate this process, let's consider the reaction 2H2G plus O2 G, 2H2Og. First, we will import the necessary libraries. Import numpy as np from Scipy integrate import quotient. Next, we will define the rate constants for the reaction. K1 equals 0.1, K2 equals 0.2. We will also define the initial concentrations of the reactants and products. H20 equals 1, O20 equals 1, H2O0 equals 0. Now we will write the differential equations for the reaction using the rate constants and initial concentrations. Def reactione T, H2, O2, H2O.
Isen y dh vo dt isen knh vo sin k vh de adero do vo dt isen knh vo sin k vh de adero dh vo dt isen knh vo k vh de adero return dh vo dt do vo dt dh vo dt. Finally, we will use the quotient function to solve the differential equations and calculate the equilibrium concentrations. Y mi ven isen h vo mi ven, o vo mi ven, h de adero mi ven, t isen np linspace mi ven, veka, ekato, y isen quotient reaction, y mi ven, t, h vo ek, o vo ek, h de adero ek isen y inna. We can now calculate the equilibrium constant using the equilibrium concentrations. Kc isen h de adero ek vo ek vo ek, print Kc. This is a basic example of how to calculate chemical equilibrium using Python. In practice, more complex reactions and systems will require more sophisticated methods and models to accurately calculate equilibrium concentrations and constants. Sample quiz. Quiz in how can you use Python to determine the reaction quotient, QC, for the reaction VO, G0 VO, G VO 3, G, at a given set of concentrations. A. QC isen so 3, VO so VO, VO, O VO, VO B, QC isen so 3, VO so VO, O VO, C, QC isen so VO, VO, O VO so 3, VO D, QC isen so VO, O VO so 3. Answer, D, QC isen so VO, O VO so 3. Explanation, the reaction quotient, QC, is a measure of the current state of a reaction and it is used to determine whether a reaction is at equilibrium or not. It is calculated by taking the concentrations of the reactants and products at a given point in time and plugging them into the equilibrium constant expression, just like we did to calculate Kc. The difference is that QC is calculated at a specific point in time and not at equilibrium. In the case of the reaction VO so VO, G0 VO, G VO so 3, G, the reaction quotient can be calculated as QC isen so VO, O VO so 3. Python code, so VO conc isen VO O VO conc isen N so 3 conc isen 3 QC isen so VO conc O VO conc so 3 conc print QC. In this example, we have defined the concentrations of the reactants and products at a given point in time, and used these concentrations to calculate the reaction quotient. In conclusion, understanding the reaction quotient and how it is used to determine the state of a reaction is important in predicting the behavior of chemical systems and designing experiments to control the conditions of a reaction. Quiz view the reaction view so view, G no view, G view so 3, G, is at equilibrium. How can you use Python to calculate the change in Gibbs free energy, dg, for the reaction? A. dg isen RTLN Kc, B. dg isen RTN of Yagonya bara Kc, C. dg isen RTLN Kc, D. dg isen RTN of Yagonya bara Kc. Answer: A. dg isen RTLN Kc. Explanation: the Gibbs free energy, dg, is a measure of the thermodynamic potential of a system, and it is used to determine the spontaneity of a reaction. At equilibrium, the change in Gibbs free energy is zero, which means that the system is at its most stable state. The equation to calculate the change in Gibbs free energy for a reaction at equilibrium is dg isen RTLN Kc, where R is the gas constant and T is the temperature in Kelvin. This equation can be used to calculate the Gibbs free energy for a reaction at any temperature, as long as the equilibrium constant and temperature are known. Python code: import math R isen 8314 T isen 298 Kc isen 0 Kc isen 0, 5 example equilibrium constant delta isen RT math log Kc, print delta. In this example, we have used the value of the equilibrium constant, the gas constant, and the temperature to calculate the change in Gibbs free energy. It's important to note that, if the reaction is not at equilibrium, the dg calculated will not be zero, but it will give an idea of how close or far the system is from equilibrium. In conclusion, understanding the Gibbs free energy and how it is used to determine the spontaneity of a reaction is important in predicting the behavior of chemical systems and designing experiments to control the conditions of a reaction. Quiz 3. The reaction view so view, G no view, G view so 3, G, is at equilibrium. How can you use Python to calculate the change in enthalpy, dH, and the change in entropy, ds, for the reaction? A. dH isen RTLN Kc, ds isen RLN Kc, B. dH isen RTLN Kc, ds isen RLN Kc, C. dH isen RTN of Yagonya bara Kc, ds isen Rn of Yagonya bara Kc, D. dH isen RTN of Yagonya bara Kc, ds isen Rn of Yagonya bara Kc. Answer: A. dH isen RTLN Kc, ds isen RLN Kc. Explanation: the change in enthalpy, dH, and the change in entropy, ds, are two of the main thermodynamic properties that describe the behavior of a system. At equilibrium, the change in Gibbs free energy is zero, which means that the system is at its most stable state. The equation to calculate the change in enthalpy for a reaction at equilibrium is dH isen RTLN Kc, where R is the gas constant and T is the temperature in Kelvin. The equation to calculate the change in entropy for a reaction at equilibrium is ds isen RLN Kc, where R is the gas constant. Python code: import math R isen 8314 T isen 298 Kc isen 0, 5 delta isen RT math log Kc, deltas isen R math log Kc, print delta, deltas. In this example, we have used the value of the equilibrium constant, the gas constant, and the temperature to calculate the change in enthalpy and the change in entropy. In conclusion, understanding the change in enthalpy and the change in entropy and how they are used to describe the behavior of a system is important in predicting the behavior of chemical systems and designing experiments to control the conditions of a reaction. Thanks for watching our tutorial on chemical equilibrium made easy with Python code. We hope you found it helpful and informative. If you did, make sure to hit that like button and share this video with your friends who are also interested in chemical equilibrium made easy with Python code. And don't forget to subscribe to our channel for more tutorials, tips and tricks on Python programming and scientific solutions. Thanks for being a part of the Code Wizard community, and we'll see you in our next video.